So now we've talked about ions. Atoms can gain or lose electrons to obtain an octet or a full valence shell, and that will give it a charge. But they don't have to have a charge to be considered to have an octet. So the other option is that atoms can gain an octet or a filled outer shell by sharing electrons. So for example, many of the nonmetal atoms, such as hydrogen and fluorine, oxygen, they gain an octet, or they exist in what we call their what's it? I'm gonna find the word. Just give me a minute. An isotope. Different forms of an element that are naturally occurring. It's on the tip of my tongue. They're called allotropes. So the naturally occurring allotrope of a lot of the nonmetals are diatoms, or containing two atoms, and that they do that in order to have an octet. So for example, fluorine naturally exists as a gas, but in that gas it takes on a molecular form of F2. And what is occurring is that two fluorine atoms are sharing electrons to each, so that each of the atoms has an octet. So we get the laser pointer. So now fluorine, the diatom, each of the two fluorine atoms has an octet simply by sharing electrons in what we call a covalent bond. Hydrogen does the same thing. A filled shell for hydrogen, which is in row 1, is to have a total of 2 electrons. So two hydrogen atoms, they share an electron in one bond, so that now each of the hydrogens is surrounded by 2 electrons. And it has a filled shell. So what are some of the other diatoms that I can think of? We have nitrogen gas. So N2 exists as its naturally occurring allotrope This is the elemental form found in nature, in air. A nitrogen gas, N2, it has each of the atoms owns 5 electrons. 5 times 2 is a total of 10 electrons. So how can they be surrounded by an octet? They form a triple bond. The 2 nitrogens are sharing 6 electrons in a bond, and then they each have a lone pair, which gives both nitrogens being surrounded by a total of 8 electrons. One of the things that you're going to be able to need to do is to determine the total number of bonds that are preferred for an atom. And so a bond is formed by sharing atoms, and that's a covalent bond. We learned about this in Gen Chem. And one of the things they probably didn't tell you in Gen Chem is a shortcut to know how many bonds an atom prefers. So I told you before that nitrogen prefers 3 bonds and 1 lone pair. It has a valence of 5. It needs 3 more electrons to get an octet. The number of electrons that it needs is going to equal to the number of bonds that it forms. So you can figure out how many bonds an atom prefers to make by taking whatever its full shell is minus valence will equal to the number of bonds preferred. So if we're in row 2, and a full shell is 8 electrons, or an octet, you can take 8 minus valence, which is 7, and we get that fluorine forms 1 bond. For hydrogen, which is in row 1, the full shell is 2 electrons. That's the maximum number of electrons that we can have in row 1, minus valence, which is 1, and we get that it forms 1 bond. Doing that for nitrogen, we get that nitrogen has a full shell is 8 electrons minus valence of 5, and so we form 3 bonds. Okay. Achieving a filled outer shell can occur by sharing electrons. But sharing electrons does not necessarily mean that those electrons are shared equally. So next topic is going to be polar covalent bonds, which I have copied a table from your Gen Chem book to show you that you've already learned this. Or maybe I erased the table because I didn't like it. It's in chapter 9, I think it's table 9.5, but it's defining what is a covalent bond, what is a polar covalent bond, what is an ionic bond. And that is done by looking at electronegativity. I'll cover that in a minute, okay? So we have hydrogen, which has 1 electron, chlorine, which has 7 electrons. If we share, each atom is surrounded by total number of valence electrons. Hydrogen gets 2, chlorine gets 8. Knowing how many bonds each atom forms can be done by looking at how many electrons does it need to form an octet. So let's write that down. How many electrons to form octet or filled shell? Eraser, can't spell sometimes. All right, so water, oxygen has 6 valence electrons. It's 2 short of an octet, forms 2 covalent bonds. Nitrogen, 5 covalent electrons, needs to form an octet, needs 3 more electrons, forms 3 bonds. Carbon, 4 valence electrons to form an octet, needs 4 more, so 4 covalent bonds. But they still have to have an octet. So if oxygen only has 2 bonds, that counts for 4 electrons. It needs 4 more. The other electrons are going to be present as lone pairs. Water, 2 bonds, 2 lone pairs. Nitrogen, 3 bonds, 1 lone pair. Carbon, 4 bonds, no lone pairs. All 8 electrons in bonds. Nonpolar and polar covalent bonds. So we need to define what they are. So a nonpolar covalent bond is a bond between atoms that have the same or similar electronegativities. And polar covalent bonds are bonded atoms that have different electronegativities. So the electronegativity of chlorine, I think, is 3.5. The electronegativity of hydrogen is 2.1, I think, ish. I can go back and look at the periodic table. Periodic table, hydrogen. Here is the electronegativity, 2.2. Chlorine, we're going to go with 3.16, okay. Going back and looking at that, we have 2.2 and 3.16. You take the difference, so about 3.2 minus 2.2, it's a little bit less than 1, so 1.94, yeah, 1.94 is the difference, and that is a polar bond, or 0.94, not 1.94. Haha, math. 0.94. So we have to define, we can actually define the bond type by the difference in electronegativity, and we'll do that on the next slide. Okay, but when we have a polar bond, we can write that one atom has a partial positive compared to the other atom, and that is based on the value of electronegativity, which is in the periodic table that you have access to. Okay, so you should be able to write in which atom is more negative than the other based on the value of electronegativity. The atom that has the higher electronegativity value, the highest one being fluorine. If you remember, electronegativity increases to the right and up on the periodic trend. So to the right and up is increasing electronegativity. And for electronegativity, I just say En. And then we can draw in our partial charges, and we can also draw in our dipole arrows, which have a plus sign at one end and the arrow moving away from the plus sign. So plus being the more positive atom. And being able to identify whether an atom has a partial positive or a partial negative charge is going to be essential when we get to reactions in this class, when we get to chapter 6.